Yeah, welcome to Easy Learning Electricity and Magnetism tutorial class on YouTube. I said welcome to Easy Learning Electricity and Magnetism tutorial class on YouTube. The course code of this is XTP121 or Physics 101. The course code of this course is XTP121 or Physics 101. We are going to treat the topic we have. The topic we have is Coulombs Law. Coulombs Law. We are trying to deal with Coulombs Law. The Coulombs Law, lesson 1. We're in lesson 1. This is the first lesson on this topic. So for you to understand that very, very well, I have to follow from the first lesson. So I have this. This is a charge. This is a positive charge. This is a positive charge. You move this way. This is a positive isolated charge, which we'll call Q1. This is a negative, another positive isolated charge, which you move this way. This is Q2. This is a charge. But these two charges is of like charge. They are like charge. So there will be a repulsion. Here, there's a repulsion. There's a repulsion. That's what pushes this man away, push this man away. When I bring like charge together, what happens? It will push backward. And what push backward? That means there is a force. For this man to be pushed backward, and you know, you move from this, from positive to what? Negative. This move from positive to negative. You move from positive to negative. That's the direction of line of force. This is the direction of line of force. This indicates the direction of line of force. So, look at it. There's a push away because they are like time. As you bring it, just as when you bring a magnetor, bring the north pole of magnetor, bring another north pole of magnetor, what will happen, you will see that magnetor will be used to pursue the other one away. Meaning there's a push, there's a repulsion because of the field. This is the direction of the field, the line of field, the field. Then, assuming that I have this negative, and I have this positive, what you see is a what? Attraction. This is what we will see. This is attraction. We see what? Attraction. We see attraction. This is charge 1. This is what? Charge 2. And this is what we call attraction. And this, the direction of field, line of field. The direction of line of field, from positive to negative, that's the direction. From positive to negative. So, this attraction, for this to be attracted, there is a force. And that force is what we call force of attraction. For this to repulse, there is a what? A force. For them to repulse, move. For me to move from this place to this place, there's a force. So for this man to repulse this man away, means there is a force. And that force is what we call force of repulsion. Repulsion force. For this man to be attracted to this man, means there's a what? Attraction. Just when you bring the north pole of what? Magnetor, and bring the south pole of the magnetor, and bring them together, what we'll see? Even the magnetor will be here, what we'll see? It will attract it. Meaning there's a force of what? Attraction is involved. Remember, before this man can be attracted, their field must be interacted. If you put magnetor far away and put the other one far away, they cannot what? Attract. They only attract when you begin to bring them close. And the field, because this magnetor you keep, there is a field surrounding it. This is the field. This line you see is the field. Around is a charge. This is the field. It's radiating around the charge. This field around the charge. So for repulsion to occur, this field and this field might have what? Make themselves. When they meet themselves, they find out that I am a positive, you are positive. No, we can't. We can't associate. That's what we call repulsion. So at this field of this Q1 meets the field of Q2, and they find out I'm coming out from positive. You are coming out from positive. No, we can't marry together. We are of the same blood. We what? Repel. But this man here is negative. This man is what? Positive. As the field was going and they come in contact with this field of negative, what will happen? They will attract themselves because they are of different field. This man is negative, this one positive. They are what? Attract. So, unlike charge attract each other, while like charge repulse. And if I have this here, Q1 here, if I have Q1 here, which is this, and this man, Q2, which is what? This, and this distance of their separation, this distance between them, R, I use R to represent the distance between them. Distance between them is R, I use R. This distance from here to here, where this man is, and this man is, look at the distance between them. The laws, the Coulombs Law is trying to state, he said that, we said that law, Coulombs Law, we said Coulombs Law states, Coulombs Law states that the force, Fe, what did I put it, Fe? Is electrostatic force. The force, Fe, electrostatic force, because this is a static charge, it's static, it's not moving. So, force, E, electrostatic force, between electrostatic force of repulsion or attraction. You see that we have two of them, either repulse or attraction, of between two charges, Q1 and what? Q2, located a distance R apart, located a distance R apart, is directly proportion to the products Q1 and the what? Q2. And the is inversely proportional to the square of their separation. To the square of their separation. Then mathematically, we have that F is directly proportional to what? Q1, Q2. Again, F is inversely proportional to what? R squared. That means F is equals to, proportional to Q1, Q2. In simplicity, that means F is directly proportional to Q1, Q2, and inversely proportional to what? R squared. That's what the law is telling us. That F, electrostatic force, is directly proportional to what? Q1 and what? Q2. That's the product. And inversely proportional to what? R squared. And this is what I'm trying to explain to you here to say F is directly proportional to what? Q1, Q2. That is directly proportional. And F is inversely proportional. That's what we call inversely proportional. This directly proportional. This inverse proportional. So this man is directly proportional to this. And inversely proportional to what? The distance of separation squared. Then now, we have Fe equals to, for equals to be applied, I have to apply what? Constant, which is called K, Q1 and Q2 all over what? R squared. And this K is constant of proportionality, where K is constant of proportionality. Constant of proportionality. And K is equals to 1 over 4 pi epsilon O. K is equals to 1 over 4 pi epsilon O. Where epsilon O is electric permittivity of the space between the two charges. Where epsilon O is electric permittivity, where epsilon O is electric permittivity, is the electric permittivity of the space between the charges, where this man is electric permittivity of the space between the charges. And what is the space between the charges? These charges are being situated in a free air, like me here. As I'm talking to you, I'm in a free air. The space between these charges is free air, is air. This experiment is done in a free air. So, this man is called permittivity of free air. So, therefore, I cannot say that EO is permittivity. EO is permittivity of free air. Permittivity of free air. EO is permittivity of free air. This EO is permittivity of free air. How did I get it to be free air? Because where I did this experiment, where I keep this charge and where I keep this charge, is in free air. So permittivity, which I said, this O is electric permittivity of the space between the charges. And what is between the space between the charges is air. So we say is what? Free what? Air. Or we call it vacuum. Free air or what? Vacuum. So this man is electric permittivity of free air or what? Vacuum. So that means I'll use this man when the experiment is done in a what? Free air. As I'm doing this, teaching you here, where I am now is a free air or a vacuum. And the permittivity of it is what? Epsilon O. Then let us look the value. Okay, let us look the value. This man, O, is equals to 8.85 times 10 raised to the power minus 12 Coulomb squared per Newton per meter squared. The value of this man is what? Coulomb squared per Newton per meter squared. Newton per meter. Newton per meter. So, or we say this man is equals to 8.85 times 10 raised to the power minus 12 force per meter. This force per meter, that's the unit of x log O. Then now, if this man is this, I have that K is equals to 1 over 4 pi x log O, and this is equals to 1 over 4 times pi is a constant. Pi is a constant which is 22 over 7. I will now times by 22 over 7 times x log O, which I'm going to have this. Pi is 22 over 7. I'm going to have 1 all over 4 times 22 over 7 times 8.85 times 10 raised to the power minus 12. And when I do that, I will have that K is approximately 9 times 10 raised to the power 9 force per meter. So when you do this, 1 divided by 4 times 6, using your calculator, result. How do you use your calculator? You press. You can simplify it by saying, if this will be difficult for you, you can do 1 all over 4 times 3.142. That's the approximate of pi. We say pi is equals to 22 over 7 and approximately 3.142 times 8.85 times 10 raised to the power minus 12. Here, you can use your calculator. How do you do this in your calculator? Press 4 times 3.142 times 8.85. After you have pressed 8.85, then you said you press what? Shift. Where you get is press shift. Have you pressed shift? Press log. Have you pressed log? You will see small 10 that appear. Press minus 12. Press minus, then press 12. You press equals to. Another way you can do it, you can bring out your calculator. Have you bring out your calculator? Bring out your calculator. Let me teach you how you can punch this in your calculator. Bring out your calculator. Let us learn how to punch this in calculator. That's the way of learning as well. Let us know how to punch it. Bring out your calculator. Press 1. Have you pressed 1? After you press 1 like this, after you press 1, then press divide. Have you pressed divide? Press open the bracket. Have you open the bracket? You press 4. Have you pressed 4? Press times. Have you pressed times? Press 3.142. Have you pressed it in your calculator? Press times again. Have you pressed times in your calculator? Press 8.85. Have you pressed it? Then press shift. Immediately I make this, what I'm going to press is shift. Have you pressed shift? Then press log. Some of you have a phone that have second function as a shift. Some certificate one is written shift. Some is written as second function. So if your own is second function, when you get here, press second function. If your own is shift, press shift. Have you pressed shift? Then press log. Have you pressed log? You will see a small 10 that will appear. That's the 10. Then you press minus. Then press 12, 1, 2, which is 12. Then close the bracket. Have you close the bracket? Press equals to. That will give you this. It will give you 8.8 or 9 something something, which you approximate. And not points. You have 8, 9, 8, 4, whatever. You approximate it to this. You make it to standard form. When you make it to standard form, you have approximate to this. So now we have learned how to what? Use what calculator as well. So here it is, your calculator. You don't need to bother. I've explained to you. You just press 1, press division, open the bracket in your calculator. You have a bracket in your calculator. You open the first one, press distance 3.142, press times 8.85, shift load, you press this, and then close the bracket. You must close the bracket before you get it. So let us go to the one we have. Now, we have seen that K is approximately to this. Therefore, when I've gotten K to this, I cannot have this to be this, the value of K. Whenever I want to substitute for the value of K, if they didn't give me the values, I can use this. Then now, what of if this experiment is done apart from what? Free air. Is done in another medium, in a material medium. That's when we said, if the charges are situated in a material medium is situated in another material medium other than free air, other than epsilon O. What of if this experiment, the charge, maybe I took this charge inside oil and position this one inside the oil and base it with oil and position this charge inside this one, position this one inside this place. How will the attraction force or repulsion force will work here? That means I'm no more in air, I'm now inside the what? That means that what the charge is no more in air. They are not performing air, they are performing inside the oil. What if I take them inside a river or water, a basin of water or a pool of water, and keep this charge here inside it, keep this one inside it? How do they attract or what repel? So in that case, when we have that, we say then K will be equals to 1 all over 4 pi epsilon. It's no more epsilon O. It's going to be what? Epsilon. But when it is free air, it will be epsilon O. But when it is situated in another medium, that's where the experiment is done in another medium, we have what? E, which is called epsilon. Where is epsilon? Where E, epsilon, is the permittivity of the medium, called or we call it dielectric of medium. Dielectric of the medium. I get it. So this becomes dielectric of the medium or permittivity of the medium, where I found that where I did that experiment, apart from what air. When this man is that, then now, hence, from this now we now know that what? Hence, the force between charges depends on the medium where the experiment is what done. The force between charges, the force of attraction or repulsion between the two charges that occur in two charges depends on the medium where that experiment is done. Just for example, if you are moving on a solid ground, the speed you use on a solid ground is not the same speed you use on a sandy sand. When you are moving in a solid ground, you move with what? Efficiency. But when you are moving in a sandy sand, you will see that your movement will be a little bit slow. So the medium, when you are moving in a sandy sand in another medium, when you are moving in a solid ground, is in air. So can we now see the effects? So we say that the force of attraction or repulsion between two charges depends on the medium where they are being situated. If they are situated in air, it becomes free air. When they are situated in oil or water or in another medium, it's not the same. Which I explained to you that when you are moving in solid ground, the speed will not be the same when you are moving on the sandy sand. Just like when you are moving inside the floor, on the floor, maybe the floor is a lot of flood on the road. When you're moving on that flood, it's not the same way you are moving on a road that doesn't have what? Flood. So, in this case, we say that what? Force of attraction or repulsion depends on the medium where the what? The charges are what? And so I'm putting it here to you to copy as a note. We said, comma. Hence the force between charges depends on the medium where they are situated. So, the force between charges, which is force of attraction or repulsion between charges, is what depends on the what medium where they are what situated. Let's see the effect of where they are situated. That means, if it's in the air becomes our reference point. When I was in air, I'm free to move. But when I was in water, there's some little distraction. So air becomes what? A perfect medium to what? Operate. Then now, let us see deviation, which we call deviation from this air. By using another medium, we say that what? ER is equals to epsilon over what? Epsilon O. This become effects and this become constants. This become how the deviation, if this man is greater than this man, he no now mean that what? The effects, the forces will be less. But if this man is greater, is the same with this man, it means that what? The force in the air and the force in that medium are the same. What am I talking about? If this man now and this man are the same, it means that this man is also acting as air. So, and then this implies that E is equals to ER, EO. This ER is what we call relative permittivity of the medium. We call it relative, where EO, ER is dielectric constants. It's called dielectric constants or relative permittivity of the medium. Relative permittivity of the medium. It's called relative permittivity of the medium. And this gives me the effects of the medium. That's the effect of the medium to the force is what this man is giving me. In some cases, they will give me dielectric constants without giving me the permittivity of that medium. I said, in some cases, they will give me dielectric constant, which is E epsilon R. Dielectric constant is the word epsilon R, which in some cases they will give me. For me to get this man, I will multiply it with epsilon O, which I've already known. This epsilon O, which we explained before, which is this, is a constant. This value is a constant, which you needed to put in your brain and memorize it. Then in a situation whereby they give me this, which is dielectric constant, and I needed to know the permittivity of that medium where the experiment is done, I will say E is equal epsilon E is equal to epsilon R times epsilon O. So when I multiply this to this, I'll have this value there. I will say from this K, we have that K is equals to 1 over 4 epsilon E. Therefore, knowing this is equals to this, I will have that what 1 all over what 4 pi epsilon R epsilon O. I use this when this man is not giving to me strength. What do we call this man? Permittivity of the medium. Permittivity of the medium. Then, if they fail to give me this, and they give me dielectric constants or relative permittivity, I will also get this by using this. using that dielectric constant to multiply epsilon O, which I know is value, I will get this value. You have seen the relationship between them. That's why we say that this man now turns to this man if this man is not the victim. Note this. Then we move where K, we move to what of when? We started by saying when K is equals to, when K is equals to 1 over 4 pi epsilon O is approximately 9 times 10 raised to the power 9 force per meter. FA is equals to K Q1 Q2 all over R squared. Then I cannot say that this is equals to Q1 Q2 all over 4 pi epsilon O R squared. R squared epsilon O R squared. And this is same thing as 9 times 10 raised to power 9 times Q1 Q2 all over R squared. When K, that's permittivity of free air, which you know as this. Having this, substituting this for this man, I'll have this. Substituting this for this man, I'll have this. So any of them goes. So I can substitute this for this man, I have this. Substituting this for this man, the same this man, I will have this. And this FA stands for what? Force exerts on the force of attraction or repulsion on the charges in the what? Free air. And that's it. FA is force inserted on charges in free air. Look at it, in free air. It's the force inserted on charges in free air. I'm using it to calculate. Then when K, somebody might have asked, how did I get this by substituting? For clarification, when I have F equals to K Q1 Q2 all over R squared, where K is equals to 1 over 4. Let us see how I will get them. Substituting 1 over 4, I will have F equals to 1 over 4 pi epsilon times Q1 Q2 all over R squared, and this will give me 1 over 4 pi epsilon O times Q1 Q2 all over 1. You remember what we said, that anything you write is divided by 1. Anything you write, any time we write is a term. Any time we write is divided by 1. R squared, that's what we learn in math 1, 2. Then this is F equals to Q1 Q2 all over 4 pi epsilon O divided by R squared. And this thing can be written as Q1 Q2 all over 4 pi epsilon O divided by R squared. And this can be written as what? Q1 Q2 all over 4 pi epsilon O divided by R squared over 1. And this can be written as Q1 Q2 all over 4 pi epsilon O times 1 all over R squared. And that will give me F is equals to Q1 Q2 all over 4 pi epsilon O R squared. And that's what I did here. When K is equal to this, I substitute in this formula, I will have this. That's what I write it. I was doing this to clear the person how I get it. I'm doing this to clear you how to get it. When K is this, I substitute here, I will have this. When I substitute this, I will have this. Now, how did I get that? That's what I was explaining here. Where K is going to substitute and I have this. Then now, what of when K is equals to 1 all over 4 pi x log and is equals to 1 all over 4 pi x log r x log o. Remember, when this man was not given to me, but what the dielectric constant is given to me, I multiply it with the x log o, I will have this man. So now when it is that, I will have that my what Fm, which will for force insert on the charges in the what medium. I will have this to be what K Q1 Q2 all over what R squared, and that will give me to be Q1 Q2 all over 4 pi epsilon R squared, and that will give me Q1 Q2 all over 4 pi epsilon R and what epsilon O R squared. When I substitute this, I will have this. Then when I substitute this, I will have this. When I substitute this in this for this one, I will have this. When I substitute this for this one, I will have this. So this is a force inserted on charges in a what? Material medium. This is a force inserted on the charges in a material medium. This is a force inserted in the material medium. So we say that Fm, I say that Fm is the force. Is force inserted, as I said, inserted on charges in material medium. In material medium, where is another medium. Then we are seeing that when this experiment is done in a free air, we make use of what? This. When it's done in another medium other than free air, we make use of what? This. Or this. You are seeing it. So what of when the charges are identical? What of when the two charges are identical? What do you mean identical? The same. That is Q1 is equal to what? Q2. That means they are identical. They are equal charges. Equal charges means identical charges. For instance, electron and proton. Electron and proton are equal charges. It's opposite inside. Electron is negative and proton is positive. Just like 1.6 times 10 raised to the power minus what? 9. Minus 19 is for what? Electron. For proton, that's plus. And 1.6 times 10 raised to the power minus 19, that's negative. For what? Electron. This is electron. Are you going to see that? This is what? Proton. They are the same charge. They have the same charge, but opposite in nature. So these two values are what? Identical. So it means that this charge and this charge are what? Identical. Despite they are what? Negative and positive, but they are identical, the same value. So when they are identical, what happens? We cannot say that what? Q, F equals to what? K. Q1, Q2, all over R squared will become what? K. Q squared, all over what? R squared. They are identical. It simply means they are what? Identical. Means that what? This one become what? The same. We said X times x will give you what? X squared. Or y times y will give you y what? Squared. This man and this man are identical. They are the same. So when they multiply themselves, just simply make one of them what? Squared. This man and this man are the same. Therefore, when you multiply them together, you simply mean taking one to square. So when they are identical, this formula you can write it in the simple form with this. When they are identical, this man and this man are identical, that is the same. We can now write it to be this. Then we can now, this now become that f for what? A become what? K Q square all over R square equals to what? 9 times 10 raised to the power 9 times Q square all over R square, or Q square all over 4 pi x dot R square. Then Fm is equals to K square all over R square, which is equals to what? Q square all over 4 pi epsilon R square, or Q square all over 4 pi epsilon R epsilon R square. You can use any of this. Either use this or this or this, they are the same. Either use this or this, they are what? The same. So when I'm solving this, what I needed, if they give me this, I use this. If they didn't give me this, if they give me this, I multiply them together and have this. So that is the case. So this, I can use this in the place of what this. So this is where we are ending this lesson of today. Remember, this channel is free. Subscribe, love this video, comment, share to your friends, love the video, share to your friends, and comment, share, and subscribe. Why you are subscribing is for you to get notification whenever we post a new topic, and we post a new topic every day by day. As we post a new topic, you will be notified if you have already subscribed. So subscription is free. So thank you for watching this video. Also, for any question or any confusion that you didn't understand any question at all, you can WhatsApp us through this WhatsApp number 080-309-37728. You can WhatsApp us through this number, but it's not for call. You can WhatsApp us through this number. We'll clear you on any question you have over what we are doing now. Thank you for watching this video. Love it, comment, share. Thank you.